and welcome to the BLSI Philosophy Series. My name is Andreas Wasmuth. I'm the co-convener for philosophy, and it is with great pleasure that I will be introducing Professor Raymond Tallis as our speaker tonight. Before we get into the introductions though, I've got a few things just to cover off in terms of general admin. And the first thing is, if you wouldn't mind at the beginning, and this is, I'm looking at Stuart here and Chrissy, to take your cameras off for the duration of the presentation. Chrissy, if you could do that as well, and Robin also, if you could take your camera off for now until we have finished the conversation. Thank you very much. Because that will help greatly with bandwidth. So, you know, obviously with today's technology, we're reliant on everybody having the same bandwidth in terms of Wi-Fi, which clearly isn't the case everywhere. And therefore, your help with this is much appreciated. On the same token, if you should be able to sort of go out of this meeting, you know, your internet fails, the only way to rejoin it basically is for you then just to click on the link that you've been provided with and join one more time. So I think that's the standard way of doing it. Hi, Dick. Do you mind taking your camera off until we finished the meeting? Thank you much, Dick. So the only other things to mention before we start is we're recording this particular meeting, and therefore if you do not want to your face to be shown on the video, then please obviously don't activate your camera later on. The other thing to mention is there's different ways of asking questions today. When we get to the Q&A and you want to be shown on the screen like I am now, you can just raise your hand in the old-fashioned way and I shall pick you out to ask a question. The other way of doing things is obviously Zoom has the ability to actually have raise your hand facility on the, you know, when you're on the right hand side. So you can raise your hand that way, I can pick you out this way. And then finally, which is the final way of doing things, is I'll be monitoring the chat room in Zoom whilst Raymond is giving his presentation, his lecture. So therefore I can also pick out any questions you may have. So for those of you who rather not ask a question in person and would like me to do it, then obviously the chat room is one way of doing that. Now, I think that covers all the admin for today. Peter, do you mind taking your camera off for the duration of the lecture, and then we'll start the cameras again afterwards? Yes, Peter, if you could take your camera off, that'd be great. Thank you. Good. I think we're ready to go. I'm looking forward to making the introductions now for Raymond. I'm absolutely delighted. This is not the first time that Raymond has been kind enough to come to the BLSI to give a philosophy lecture, and his fame precedes him. He is a clinical scientist and has spent a lot of his time writing publications in the non-scientific field. I think he's written 36 published books, and some of them are my favorites, and even the titles resonate with me. In Defense of Wonder is a fantastic book. I think The Kingdom of Infinite Space is another one. And one of my favorites is Aping Mankind. And I think coining phrases like Darwinitis and neuromania clearly shows that Raymond hasn't swallowed the pill of reductionist materialism and scientism, despite the fact he's a scientist. And it's with great pleasure that I would like you to put your virtual hands together for Raymond Tallis. Over to you, Raymond.
Oh, well, thank you very much, Andreas, and indeed, Don, for inviting me back. The reason I'm back again is I had such a lovely time last time. I have somewhat regret that I'm not in Bath in person, which is a shame, because I love your city, and we talked about the lovely restaurant we went to last time, Martini's. So who knows, perhaps a third time, if I'm invited back, we might actually physically all be together in Bath. But thank you very much indeed for turning out virtually for this talk on time travel and other myths about time. And this talk is based on a very fat book that I published a couple of years ago, a little bit longer than a couple of years ago, called Of Time and Lamentation, Reflections on Transience. It's a great fat book. If I wave it in this direction, you can see how fat it is. It's 720 pages of small print. And indeed, the paperback version is just as big. Nothing's left out. But nonetheless, you'll be glad to know I won't be going through every aspect of the book. I'm going to talk about some questions that you may find tasty. The book itself was divided into 3/3. The first was a critique of the reduction of time to a physical parameter. That section was called Killing Time. And I asked various questions like, why do we think of time as a bit like space? Does time flow? Is there an arrow of time? Is time travel possible? And that's the big question I'm going to spend quite a considerable amount of my talk on, because it brings together quite a lot of the issues I'll have covered already. Is time and indeed reality ultimately mathematical? And here's a question perhaps for Q&A. What do clocks do? What does it mean when we say a clock tells the time? I may not get round to that, so maybe one for Q&A. In the second part of Time and Lamentation, the book I've just talked about, I talk about human time, having moved away from time as seen through the eyes of physics, and in particular, the tensed time. Now, tensed time has no place in the physical world as seen through the eyes of physics. There's the present, living time, and now. There's the past. The section on the past is called Locating the Snows of Yesteryear. It's an echo of a beautiful poem by Villon, François Villon, who was a medieval French poet, who said, Mais où sont les neiges d'antan? Where are the snows of yesteryear? And then there's a chapter on the future. The future's existence today. What existence does tomorrow have today? And then I leave tense behind and talk about eternity, some temporal thoughts on eternity. And then the final section, I come back to the question, what is time? How does time relate to causation? Something I will touch on. And the relationship between time and human freedom, an absolutely fundamental question that particularly connects tensed time with human freedom, but something for another occasion, perhaps if I'm invited back, if I behave well tonight. Well, time is rather complex, isn't it? I mean, at first glance, you can see it's complex. There's the question of temporal location, the when question. When did something happen? There's the temporal order question. Which came first? What sequence did events happen? What temporal sequence did events happen? And then how long did they take? So there's location, there's order and duration. So already time is complex. But let's cut to the chase. Let's try and find out what time is. Well, a definition that's often given is that time is our perception of the sequence of events. Now that's wrong for at least two reasons. Firstly, it's rather circular, as we will find other definitions of time are. What it says is time is our perception of the temporal sequence of events. So clearly that's circular, isn't it? But it's got another more important fault. Basically, if we connect time with perception of events, then we must connect time with conscious beings. We all of us know that there were temporal sequences of events before there were human beings on the planet. We know, for example, the Big Bang occurred before the solar system came into being. The solar system was there, or in embryo, before the Earth was created. The Earth was before life, life was before conscious life. So you can see already there's a sequence of events way before there was anybody or any creature perceiving them. So that particular definition of time bites the dust on many counts. Time is what stops everything happening at once. That was, I think, Richard Feynman. He meant it jokingly. But you can see again, it's circular. It says time is what stops everything happening at the same time. Circularity. Then there's another definition. Time allows change without contradiction. Supposing I say Raymond Tallis is in Stockport, and then I say Raymond Tallis is in Bath. Someone will say, well, one of these must be true and the other must be false. I say no. Raymond Tallis is in Stockport at T1, time 1, and he's in Bath at time 2. He's in Stockport on Wednesday and in Bath on Thursday. But really that doesn't capture what really time is. Because in a way, again, implicitly it's circular. Because it says essentially, time allows there to be a change in time without contradiction. Hugh Muller, who was a very interesting and important philosopher of time at Cambridge University, said that time was the causal dimension of space-time. There were 3 spatial dimensions and a 4th temporal dimension, and that was the causal dimension. We'll come back to that in due course. Again, I think it was Richard Feynman who said, time is what happens when nothing else does. Again, a bit jokey, but actually not only jokey, but wrong. Or at least, maybe wrong. Does time, as it were, pass in any way of its own accord in the absence of any events taking place? Well, not as if you embrace the Einsteinian concept of time, which is that time is the relationship between happenings. So Einstein would say, or the earliest Einstein would say, that if there are no happenings, then there are no relationships, so there's no time. I have to say that that was the special relativity view. Later on in general relativity, he felt that time perhaps was substantive after all, or rather space-time was. You remember that there's this interaction between mass and space-time, such that gravity is curvature of space-time, and so on. So basically, that doesn't work either. But another definition is time is the overall direction of becoming of the universe. And this brings us to the idea of time's arrow. And several candidates have been offered as the arrows of time. Many of you will be familiar with thermodynamics, the second law of thermodynamics, which said basically that the disorder in the universe increases with time. Available energy increases with time. So you might have something that's neatly ordered, and then gradually it'll get more and more messy with time. That entropy increases with time. And the reason why this is the case is that in a randomly changing system, you're going to get increasing disorder because there are many more ways of being disordered than there are being ordered. That's what Boltzmann realized when he tried to understand the second law of thermodynamics, the fact that there was increasing disorder with time. So one of the most frequently touted arrows of time is the thermodynamic arrow, that basically you can translate earlier to later into less disordered and more disordered. But again, we have this problem of circularity, because basically how do we decide something is an earlier state of the universe and something else is a later state of the universe? We have to give them time labels before we can even observe the second law of thermodynamics at work. Now we come back to something I mentioned earlier, which is the notion of time as the causal dimension of space-time. Philosophers talk about the asymmetry of influence. Causes bring about subsequent effects, but effects cannot bring about their prior causes. So lightning causes thunder, but the thunder doesn't cause lightning. This is the asymmetry of influence. And again, people would say, well, that is an arrow of time. But again, we need to find some way of saying this event happened first and that event happened second. And we can't do that without having the notion of time in place already. So we can't translate time itself, or the flow of time, and I'll come to the word flow shortly, into this asymmetry of influence, into the relationship between causes and effects. People have suggested that the difference, that the arrow of time is the difference between memory and anticipation. That you remember things in the past and you anticipate things in the future. You cannot remember the future. But again, this makes time, or the arrow of time, or the so-called direction of time, totally dependent on sentient beings, in particular on human beings, who have a sense of tensed time. So again, that doesn't work. That's been translated for some as the arrow of time is the direction of increasing information. We know more at T2 at a later time than we know at T1. I know more on Wednesday than I knew on Tuesday. Again, unless you use the word information in a very broad and, to me, illegitimate sense, then it seems to try and capture the arrow of time within human consciousness, and that clearly, or the consciousness of organisms, and that somehow doesn't do justice to time, which we would expect and anticipate basically was there before sentient beings came into place. So we've made absolutely no progress, but I'm not at all upset by this. And I want to quote from a very good philosopher of time, Quentin Smith. Time, he says, is neither causation, motion, physicality, mentality, nor anything else. Time is time. Time is a series of items related by primitive and irreducible relations of earlier, later, and simultaneous. So I don't think we can translate time into anything else. And I think that's a very important point. It is primitive and irreducible. There's things to be said about it that can't result in its being translated into something else. So it's a real standalone mystery, something worthy of discrete and distinct attention. I mentioned that the first part of Time and Lamentation was called Killing Time. And it's basically what the assumption that natural sciences have the last word on time, what that assumption does to time. The most obvious thing is it reduces time to a parameter, little t. We'll come to little t in a second. And that's the view of time when the world is reduced to the physical world and the physical world is reduced to the world of physics. When the world is reduced to a system of magnitudes, which is the world seen through the lens of fundamental natural science. Though those who believe that actually is the most accurate, faithful portrait of the world, as a result of which physics is the last word on metaphysics. If you want to understand the metaphysics of time, you need to look to the physics of time. If you want to understand the metaphysics of space or matter, then you look to the physics of space and matter. Physics will tell us what reality ultimately is. But I will put it to you that basically we do time a disservice by reducing it to little t. However, behind that is a belief, a conviction, a faith that really the portrait of reality as it is essentially should be a mathematical portrait. Of course, for many of us, mathematics is just a tool for dealing with a world we've reduced to pure quantities. That's fine, I have no problem with that. It's a tool. But for some, mathematics is seen as generating the most complete and faithful portrait of the world. So time reduced to little t, reduced to a number, 6 seconds or whatever, is time really captured in its essence. Of course, behind that is a Pythagorean or Platonic notion about the relationship between mathematics and reality. It's the idea that mathematics is the ultimate reality of the world. Pythagoras is being accused of saying all is number, but actually it was a libel placed upon him by Aristotle, who described Pythagoras' view as the belief that all is number. But actually, I don't think that was entirely Pythagoras' belief. But there is this notion that if you drill down and get to fundamental reality, that reality will be essentially numerical. In fact, consist of mathematical objects. Well, my own feeling is I'm happy with mathematics as a tool, not for dealing with the world as a whole, not for dealing with you and me and so on, but dealing with a material world reduced to pure quantity. Resist the reduction of time to little t. Because there are all sorts of regrettable consequences of reducing time to little t. You know, you would have seen time multiplied by itself, t squared. You've seen it subjected to an incredible indignity of being placed under space. When we talk about velocity, we divide spatial distance by temporal duration. So there's time underneath, as it were, as the denominator underneath the numerator of space. And that does no justice to time. It can even be multiplied by the speed of light, which I suppose is enjoyed, but I can't really see that is doing time justice. I mean, try multiplying a night with a crying baby by itself, you know, night squared, or putting a bargain break weekend in Bruges under some spatial distance, or multiplying the duration of a medical career by the square root of -1. But this is the kinds of things that are done when time is reduced to a purely quantitative parameter. And one of the reasons why it can't be reduced in this way is we've missed out a basic aspect of time. This is tensed time. I've already mentioned location, order of events, duration of events. But this is something which is in no way reducible to quantity, to numbers. It is tensed time. The difference between the past, the present, and the future. As those of you who are familiar with relativity theory, or indeed with pretty well all physical theory, there's no place for tensed time. Basically, the time of physics is tenseless. And Einstein was very aware of that. And despite his huge achievements, being a wonderful man, he was always dissatisfied with what he'd achieved. And he was dissatisfied with the fact that tensed time disappeared from both special and general relativity. And he regretted it bitterly, although he sort of believed it. And I want to tell you a little story. You can see these two characters, really nice, lovely people. On the right is Michele Besso, who was Einstein's great old friend from his very early days as a teenager and early 20s. He and Michele Besso formed a little group called the Olympians when they talked about profound philosophical questions and questions in physics. So he'd known Besso for 50 odd years. And on the left there, or my left anyway, there's his wife, Mrs. Besso. Besso died in the early 1950s, and Einstein wrote a letter of condolence to Mrs. Besso. Now Besso has departed from this strange world a little ahead of me. And then, that means nothing, he says. Consolation or what? People like us who believe in physics know that the distinction between past, present, and future is not real. It's only a stubbornly persistent illusion. But he didn't really believe that. And here's an excerpt from a conversation that the great analytical philosopher Rudolf Carnap had with Einstein. Once Einstein said that the problem of now worried him. He explained that the experience of now means something special for man. I've added, you bet. Something essentially different from the past and future, but that this difference does not and cannot occur within physics. So there's something absolutely fundamental missing from physics, fundamental from time as it's seen through the lens of physics. And Einstein was unhappy about this, that this experience cannot be grasped by science, seemed to him a matter for painful but inevitable resignation. And actually in that same conversation, he indicated that he was very unhappy also that in his physical world picture, there was no place for measuring rods and clocks. There were forces and stuffs and so on and so forth, but measuring rods and clocks didn't seem to fit into that world picture. And we could talk about that on some other occasion. It's because basically there's no space within the physical world picture for the viewpoint of the subject. And all measurements, special relativity, are viewpoint dependent. They depend on a frame of reference. And those frames of reference basically do not form spontaneously in the material world. The material world isn't a blizzard of 0, 0, 0, zeros of, as it were, points of origin. Here's a little quote about the present. What day is it, asked Pooh. It's today, squeaked Piglet. My favourite day, said Pooh. And of course, we all share that. No wonder Einstein mourned the lack of today or now in physics. So here we have the problem of time reduced to little t. It becomes tenseless. It becomes a pure quantity. It's also reduced to something called the fourth dimension, and this is bringing us close to our seductive myth of time travel. The journey to time as the fourth dimension was a long journey. It was implicit in mechanics since the scientific revolution kicked off by Galileo, and it became absolutely standard in relativity theory. And in particular, the marriage of time and space made time just one of 4 dimensions. Time became space-like. And it's because of this that time travel seemed potentially respectable rather than a fairy tale. And some of you may be familiar with this very famous quote from Hermann Minkowski from a paper he published in 1907, only a couple of years after after Einstein's paper on special theory of relativity. He said, after special relativity, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union will preserve an independent reality. So in other words, there's no such thing as separate space and separate time. That already raises a question as to why time became spatialized rather than space became temporalized. And the reason for this is it's our way of representing time. Also, by the fact that time is outnumbered by the three spatial dimensions. What are the four dimensions? Well, the three spatial ones are the x-axis or dimension, up and down, y, side to side, z, back to front. And then we have this time t. The D'Artagnan, the three musketeers of the spatial dimensions. And you can see how familiar we are with representing time as space within science. See, the vertical axis is distance, and the horizontal axis, which is time, is also presented spatially in a classic sort of graph showing trajectory of an object or some relationship between two parameters. Also, we make time explicit through the most spatial of our senses, through vision. We externalize time by seeing it. And that goes back a long way before the scientific revolution of the 16th century. It goes back to the early measurements of time, to the obelisks and all the other things, which were used to record and measure time. And here you can see a sundial, and you'll see how the passage of time will be translated into the passage of that shadow over the surface of the sundial. It's a lovely quote I came from the other day by Lichtenberg, who said, "O God, who winds our sundials." But that's got nothing to do with our talk today. And of course, more familiarly, the clock, we represent time, the passage of time as movement in space. I want to go back to Minkowski now, because the result of Minkowski is we have what's called the block universe. We have this four-dimensional space-time continuum. And basically, there's no dynamism in time. In a sense, it could be represented as a slice. So if you cut across the space-time continuum at a particular time, particular foliation as they called it, you seem to have this static slice. The slices don't move. You just take a series, basically, of slices at any given particular time. So there's no dynamism, if you like, in Einstein's block universe, no dynamism to be translated into time. Time becomes on a par with space. I've just said no dynamism in time. Should I mourn that? Well, perhaps not, because the idea that time flows is a rather odd idea. We talk about the passage of time. We talk about Christmas coming near. We talk about how slowly time passed when Tallis was giving his lecture. You know, I thought it had frozen into eternity and so on and so forth. But does time flow? Well, do dimensions flow? How could a dimension, if time was a dimension, how could it flow? But even if we set that aside, what would time flow in? People suggested it might flow in hypertime, second order time. If so, how quickly would it flow? Perhaps it would flow 1 second per second. But what a strange thing to say about anything where you have the same parameter on the numerator, I beg your pardon, and the denominator. Seconds per second doesn't make sense. So how do we get the idea that time flows? Well, of course, the world is dynamic. It's always on the move. And so we project the passage of events in time into time itself. An awful lot going on, dynamism in the world, and we think that of the dynamism of time. And that becomes particularly obvious when we start basically measuring time and we see the kind of movements we see on the face of a clock. Then it looks as if there's such a thing as a passage of time. But it's not the passage of time at all. It's basically the succession and ongoingness of events. Well, we've sort of given ourselves a background to address the issue of time travel. And I'm going to show this myth of time travel, no mercy. Basically, I've been so far tough on the causes of the myth. Now I'm going to be tough on the myth. Many of you will recognize this character. It's H.G. Wells, an absolutely wonderful writer. And I can remember reading the book, The Time Machine, when I was a child, being utterly engrossed by it. And some of you may remember this passage early on in The Time Machine, when the time traveler sets out actually what experiences, or the background to his experiences. He sets out the possibility of time travel. Clearly, the time traveler proceeded. Any real body must have extension in 4 directions. He means their dimensions. It must have length, breadth, thickness, and duration. So there are really 4 dimensions. 3 which we call the 3 planes of space. We would call them the 3 dimensions of space. And the 4th dimension, time, which is our little t. And this is the key passage in italics, my italics. There is no difference between time and any of the 3 dimensions of space, except that our consciousness moves along it. Now that's a very interesting concession, and it shows how for the spatiotemporal space-time block, in order to get it going, it requires consciousness, of course, which has no place in physics. But where on earth do we get the idea then of time travel from? Well, there's no problem with space travel. I can go anywhere in space. I can go left, right, up, down, forward and back. I can travel at the speed of my choice within limits. I can choose my here. I can choose London, Stockport or Bath. I can choose my destination. So if time is a dimension like space, why can't I travel in time at my own discretion? Well, I do in a sort of way. There is what you might call admissible time movement. I sort of go forward from 12 noon on Monday to 12 noon on Tuesday. It takes me 24 hours to do so, but I do move. But it's not, as it were, voluntary. It applies to all objects, to we, you and me, the rooms we're in, and indeed Vesuvius. And the point about it is compulsory. I cannot choose not to go forward 24 hours in 24 hours time. It's compulsory. So my movement in time is not travel. It's not time travel. It's not voluntary. And I think it's important to distinguish between travel and movement. Movement merely happens. It's not something that I do. Travel, by contrast, is a form of movement that is voluntary, elective and directed. And so, of course, I can make all these choices in relation to space. I can choose my here, I can choose to be in Stockport, I can choose to be in London, I can choose to be in Bath, but I can't choose my now. My now is not chosen. As it happens, it's now 8:05, and I have no choice about that. That's my now. Same as, roughly, same as your now. Slight difference allowing for the distance between us. So now is, for me, is Tuesday evening, whether I like it or not. Indeed, my now is not my now in the way that my here is my here. It's everyone's now, everyone within a certain light cone. Okay, so clearly I've just referred to a sort of fairly respectable form of time travel. It's not really time travel, it's movement in time. It's not voluntary, it's not travel. But perhaps there's mental time travel. It is, I would put, unique to humans, although perhaps we can discuss this in question time. Some ethologists have claimed that other creatures are capable of the sense of thinking about the future and referring to the past. Some beautiful work done on scrub jays and so on, but I don't think at the end it really indicates they can have mental time travel. But the fact remains is I can recall past events. I can recall the nice conversation I had with Andreas just before this talk. But of course, I'm not generally traveling back to that conversation. I can't actually revisit it. I can also imagine future events. I can imagine a Q&A that's going to happen in a little while. Of course, it might not happen. Everything might crash and so on. So I clearly cannot travel to an event that might not happen. Anyway, this mental time travel isn't travel in any sense that the physicists would recognize. I would add, in brackets, mental time travel is essential for free action. Tense time with the ability to anticipate the future and draw on the past is essential for free action. But that's for another time. So yes, there is mental time travel, but it's not what we're talking about when we're talking about H.G. Wells type time travel. Because one of the critical things in real time travel, the sort of time travel gets everybody excited, is a discrepancy between your personal time and the world's time. where you are in time and where the world is. David Lewis, the philosopher, summarized it follows. He says that time travel involves a discrepancy between time and time. The separation in time between departure and arrival, which doesn't equal the duration of the traveler's journey. Let me explain that. Supposing I manage to travel to the future. I arrive at next year, but I don't wait a year for it to happen. It happens in a journey that takes a week. So that's genuine time travel. Or when I travel at the past, I arrive at 2010 in a journey that takes place in 2020, so far as the rest of the world is concerned. And I arrive at 2010 when the rest of the world is in 2020. So that's genuine time travel, a discrepancy between my personal time, where all the events in my life are happening, and world time. Okay, so that's what time travel is. It isn't the kind of involuntary movement, forward movement in time that all objects, including human objects, participate in. It's not merely mental time travel, it's physical time travel. Now, I could talk about journeys to the future or journeys to the past, but just to simplify things, I want to talk about journeys to the past. And I want to focus on the troubled journey of the time traveler, the difficult arrival, and her impotence when she arrives. So let's talk about the troubled journey. It's jolly difficult to travel through the past because it would be a one-dimensional movement through space-time. In other words, I would move only in time, but not in space. Now, normally, when I move in both time and space. So basically, me, a four-dimensional traveler, would have somehow to move only in time. And that would be analogous to squeezing along an infinitely thin line. Supposing I was going from 2020 to the past, to 1066, I wanted to visit the Battle of Hastings. Well, not me, my time traveler. Now, supposing she's going from 2020 to 1066. While she's traveling, she's going in the opposite direction to that of causation. Because causation, as we've discovered, goes from cause to effect, from the earlier cause to the later effect. So she's going in the opposite direction to causation. But she has somehow to reassume normal causation when she arrives at her temporal destination. She has to put on the brakes and also resume causation when she wants to do things, when she arrives. So she's sort of picking up causation, she's setting aside causation, going in a counter-causal direction, and then she's picking it up again. That's a bit cheeky. So if you think about the time traveler, the usual order of things is the universe at T1, earlier time 1066, unfolds to the universe at T2, 2020, causes resulting in effects. What the backward time traveler needs to do is to go from the universe at T2, 2018 or whatever, to the universe at T1. Has to go from the effect to the cause. And you can see how that clearly is countercausal and therefore not possible. Because there's what the philosophers would call an asymmetry of influence built into causation. Prior causes bring about or raise the possibility of later effects, but later effects could not bring about or raise the probability of earlier causes. So that's the big trouble that faces the time traveler. She has to discard causality, the asymmetry of influence between past and future, in order to be able to travel backwards in time. But at the same time, she relies on forward causality for the journey to be started, to be maintained and stopped. What a mess, what a muddle, what an impossibility. So much for the journey. What about trying to arrive? Where is the traveler arriving at? Well, if it's purely a temporal backward journey, she must be arriving nowhere in particular. The goal is defined by a time destination, e.g. my childhood or 1066, but that doesn't correlate with any particular location. But supposing she chooses a location as well, will the destination be intact? Surely it will be altered in the interim. Supposing she wants to go back to the Battle of Hastings, in the field where it took place. Well, clearly there's going to be a problem, because the field where it took place will now essentially be, shall we say, a housing estate. So what is the state of that field? Is it the state it was when William the Conqueror conquered, or would it, and caused ophthalmic damage to King Harold, or would it be the housing estate with the pub that it is now? Would it have two simultaneous states? Two simultaneous states at 1066, corresponding to its state at 1066 and its state at 2020. Or you may say, well, no, actually, when I specify my destination, I'm not going to mention something like a field, which of course will change. I'll just give a coordinate destination. But of course, the coordinate destination will still correspond to something if the traveler is going to land somewhere. And it'll still have the problem of being in two states. The state it was in when the state it was in at the time the time traveler is seeking to arrive at, and the state it is in basically when the time traveler set out on her journey. What is the target anyway of a time traveler? Is it in fact a fat time slice, or is it something exact like 12 noon 14th of October? Okay, she touches down at the particular time slice, 12th noon 14th of October. Now can she break out of the time slice by usual causal means after she's touched down? So much for the troubled journey, so much for the difficult arrival. But what about doing something when she arrives? A lot of stories about time travel are all about going somewhere to right some wrong. For example, the time traveler goes to prevent an assassination or whatever, something like that. But actually, can the time traveler do anything at all? Let's supposing she sets off from 2020 for 1953. She arrives the day her parents meet. She waves at one of them so they don't see each other. As a result, they don't get married, and they don't have her as a baby. She's not born. So her journey to 1953 has made that journey to 1953 not possible. She's arrived at a place as a result of a journey which she could not set out from because she wouldn't have existed. So clearly there's going to be some limits on what the time traveler can do on arrival. She's not going to have much of a work permit. In fact, she mustn't do anything that will alter the future at all, including that part of the future that is the possibility of the time traveler setting out. So obviously, she can't murder her parents or whatever. She can't stop them meeting because she wouldn't have come into existence. But actually, everything else she might do is also forbidden. Even the slightest actions that have the slightest consequences. MacTaggart, wonderful philosopher, although I disagree with him, emphasized the connectedness of all things. The fall of a sandcastle on the English coast changes the nature of the Great Pyramid. The point about that is you cannot make a small change without the risk of uncontrolled greater changes. Everybody familiar, I guess, with the butterfly effect. The fact that you get non-linear consequences of small displacements under certain circumstances. The butterfly effect is the legendary effect of a butterfly whose wings are flapping in Glasgow, that due to non-linear consequences, due to a series of accidents and particularly favorable conditions, can result in a hurricane in South America. The most important thing about this consideration is that, or chaos theory as it's called, is that basically any effect or any event can actually have uncontrolled and often disproportionate consequences. So our arrivee is not permitted to interfere with the world at all, because it meant sent ripples running that may interfere with her own coming into being as a person who could then travel in time. So she can't do anything like walking, eating and drinking. She can't breathe because these all have uncontrolled causal consequences. And she's not even permitted to be aware of what is happening at her destination, because even looking involves causal interactions. No footprints, no handprints, no eye prints. Well, you think I probably wrecked the case for time travel, but there are actually even more fundamental arguments. One is to develop a point I've made earlier, that travel, unlike mere movement, is voluntary, goal-driven activity. But there's no place for voluntary activity in the block universe presupposed in time travel. There can be no individual initiation of events because there's no here, no there, no now, no I. In the block universe, the past and the universe are in place, coexisting with the present. The die is already cast. This is an inevitable consequence of freezing time and spatializing it. Time is spatialized, the universe frozen. Nothing happens because nothing happens at a particular time, at a particular global time. So no time travel or any voluntary activity could be possible. Don't take my word for it. Take the word of Hermann Weyl, a great physicist and philosopher. The objective world, seen through the lens of the block universe, the four-dimensional universe that seemed to make time travel possible, the objective world simply is. It doesn't happen. Only to the gaze of my consciousness, crawling upward along the lifeline of my body, does a section of this world come to life as a fleeting image in space, which continually changes in time. And that clearly is not part of the spatiotemporal continuum of the block universe, which seemed to give permission for time travel. It's interesting that Einstein accepted that interpretation, and one of the philosophers he admired most was Spinoza, who was a determinist. And Einstein felt that all was determined by the laws of physics. He felt that free will was not possible, and that fits entirely with his notion of the block universe. There's no way to choose or initiate an event. Even if anything could happen, it could not be voluntary. It could not be something like setting out for a goal, traveling, arriving, and acting. All those things that the time traveler wants to do. And in fact, Einstein accepted the sobriquet of being called the Parmenidean from Karl Popper. This is Parmenides, fine-looking lad there, and many of you will know that he was a great pre-Socratic philosopher. I've written a monograph on him, and his ideas seem most unpromising, but they are profound. And he argued, for all sorts of reasons, which perhaps we could discuss, that change is unreal, that the world is an unchanging, uniform, unbroken totality. And that's the world of the spatio-temporal continuum, of the general theory of relativity, of the idea of a four-dimensional universe. So let's just wrap things up. The argument for time travel is this. Time is a dimension. It's analogous to space. If you can go from any place to any other place, why can't you go from any time to any other time? Well, this is why. Time is not just a dimension. The analogy between space and time is false. Time is not just little t. And if the universe were a spatio-temporal block, there would be no traveling. Certainly no time traveling. I'm just going to end up with a couple of comments from Leif Smolin, a physicist I admire enormously, who mourns the fact that time has virtually shriveled away in physics. I've mourned the fact that it's disappeared to little t. He wonders whether it's disappearing altogether, and attributes the crisis in physics to this. Crisis of physics you'll be familiar with, how we've got stuck since the Standard Model of 1974, how there's incompatibility between quantum mechanics and relativity. The whole history of physics, he says, has been a history of diminishing the nature of time, diminishing the role of time. So we begin with Galilean physics, which reduces time to little t, and we continue, and time gets more and more marginalized. It loses all that richness and thickness of the time as we experience it as human beings, the tense time of the past, the present, and the future. And he says that cosmology is present in a crisis, and the essence of this crisis is understanding the nature of time. Well, those are some of the things that I've written about in this rather fat, perhaps too fat book. But I think it's time, I guess, for me to stop I hear a quote from Humphrey Lyttelton, wonderful comedian. He used to say at the end of I Haven't a Clue, I hear the tortoise of time explode in the microwave of eternity. And I think you're probably feeling the same. So at this stage, I'll stop and look forward to your questions. Thank you.
Well, thank you very much indeed, Raymond, for this timeless journey through time. I think, I mean, there's definitely a tour de force. We covered off various other aspects that are clearly related to time: free will, determinism, consciousness, relativity, tense time, block time. I think this leaves plenty of thought for the Q&A. So
Thank you.
I think really a big thank you to you for a real tour de force through the whole
thank you.
It's much appreciated. You may want to unshare your screen at this point.
Oh,
so,
yes.
Yeah.
So if I press the knob there, is that right?
Yes. Share, and then that should.
Oh, yeah. Oh, yes. And now I can't see anybody. Is that a mistake?
No, you just need to unshare your screen. Let me just make sure you.
Oh, I see. Yes, I get rid of that.
Yeah. So where you shared previously, you can now unshare your screen.
Oh, yes. Thank you.
And we're back. Now that's been excellent. So I think this now gives us everybody on the call. Now this is the time for you to obviously share your camera if you want to be on this call, which is going to be recorded. You can certainly unmute yourself in terms of asking questions. I've been looking at the chat room. There's nothing that's sort of jumped out at me. You're obviously absolutely focused on Raymond and various dimensions of time. So I think it's been an excellent talk. Thank you very much indeed once again.
Oh, thank you.
I'm sure by the time we get to the end of the Q&A, we can all unmute and give you a big round of applause for all that effort and all that time we spend. So I think we're going to throw open the Q&A, and as I said, I'm going to monitor the chat room as well. So if anybody wants for me to read out a question rather than ask itself, then that's absolutely fine. Otherwise, please show your hand in the usual way to ask a question, or raise your hand virtually in the Zoom forum, which you can do as well. So who would like to go first with a question? Everybody's awestruck. Okay, I've had something here from Bas Verplanken saying, question about astronauts. Bas, do you want to unmute yourself and ask the question?
Yeah. First of all, thank you very much for your very interesting talk.
Thank you.
I would like to ask, well, what about the observation that astronauts who have been flying through space, once they're returned to Earth, they're a little bit younger.
Yes. Yeah.
So isn't it that sort of time travel in some sense?
That's interesting, isn't it? I mean, this is being developed with the twin paradox in particular, isn't it? Because you have two twins, and one who has a very extensive journey which involves acceleration and so on, will have a different aging process from one who remains on Earth. I've never quite understood the twin paradox. And basically the notion that you age less when you are, as it were, not accelerated. I don't quite understand it. But I don't think it, as it were, in any way opens one up to time travel. Do you feel it does, or the possibility of time travel?
I'm not a physicist at all, so I also don't understand the mathematics of it. But what I understand is if they would have taken a clock with them, you would actually see the difference in time.
Yeah.
So the person who stays on Earth can tell her twin, so to speak, what is going to happen. So it's a very intriguing phenomenon.
Oh, that's interesting. Are you sure about that? I never come across that manifestation of the twin paradox. I mean, they age differently, but I'm not too sure that either of the twins, the one who stays on the Earth and the one who goes into space and accelerates near the speed of light and so on, I don't think either of them is able to see things in advance from their own?
I don't know that. The only thing I know is that they measured clocks.
Yes, absolutely, and
they measured the difference.
And that I accept, and that's a natural consequence of special relativity. But I don't think that would then, as it were, enable you voluntarily to choose to dart around time.
No.
Neither of the astronauts basically gets a better grip on time through being either in the rocket or staying on Earth. But what do you feel?
No, I don't think they can take advantage of it.
Exactly, that was the word I was looking for. Yes, exactly.
To put it in another way, but it does to me. It does sort of suggest or demonstrate that time is not the one movement that we all now experience.
Well, exactly. I mean, there isn't a single frame of reference. Absolutely, there isn't a global clock that is accessible to individuals who are experiencing the world, or indeed individual objects that are located in the world. You know, the twins' bodies age at different rates.
Yes, I think the clockwork universe went out with Newton, I think, and or certainly with Einstein after Newton, put it this way. So, now very good. Thank you, Buzz, for your question. Anybody else? There must be loads of questions. So far, we've only looked at the twin paradox. So, again, unfortunately, I don't know your name, so I have to refer to you as iPad. And if you could unmute yourself, that would be great.
There were 2 points, really. One about time as a dimension. I mean, after, and I use the term after carefully, Minkowski and then Einstein, we had 3 dimensions of space and 1 of time.
Yes.
And time is very much a different type of thing. After Minkowski and Einstein, there became one thing which had 4 dimensions, which was space-time.
Yeah.
And people who are traveling at different speeds relative to each other, they disagree about exactly what is time and what is space. So that if you're traveling at the speed of light relative to me, as far as I can see, you don't move at all. Therefore, there's no movement through time because you're not actually doing anything.
Yeah.
So it's as I say, from Minkowski on, there's a thing called space-time rather than a thing called 3 things called space and 1 of time, and people traveling differently to each other see them differently. They've actually got different axes of what is time and what is space. But as the physicists would see, there is this stuff that they do their calculations with, which is called space-time. The other thing about traveling through time, your time traveler moves back to 1953 when her parents were just about to meet each other and go on to have a whirlwind romance, the effect of which was your space traveler later on.
Yes.
Now, so your person arrives back in 1953 and stops them meeting each other. Now, if you think of them as traveling, if you like, on a spiral, so that when she gets back there, she stops her parents meeting. So you can have different universes, or it's imaginable to have different universes happening at the same time. So, I mean, that's become a relatively common idea in physics that you get parallel universes, and therefore in the universe that she's, if you like, interfered with, stopped her parents meeting each other, then she would never be born. But that's not to say that there isn't a parallel universe in which they did meet each other, and she was born, which is the one she's travelled back from. So if you like, there are 2 parallel universes, one where her parents met each other and then she's born and then goes back. And then there's the one starting from there in which her parents don't meet each other, and she's never born. So there's a universe in which she is born,
I don't think we're allowed
and a universe in which she isn't born, and that seems to me plausible.
It's quite
Not
interesting.
really.
It's great that we've reached multiverses and string theory.
Yes,
I-
well,
I-
quite.
I was going to
Yes.
say,
So we're
I
going to
mean-
be testing your quantum mechanics and
Yeah.
relativity at once.
Yeah, but basically, I don't think one's allowed to invoke the multi-universe solution to the puzzle of quantum mechanics in a macroscopic Einsteinian world. It just isn't the case. Clearly, the idea of multiple parallel universes is to do with quantum indeterminacy, but there isn't this kind of indeterminacy at the macroscopic level. So I don't think one can invoke it. I mean, you may be using a parallel universe, but not in the way that it's used in the respectable sense.
No, I'm using it my own. I'm using it in my own personal way.
Yeah.
Just to say, well, you could have two parallel universes. One of which the parents meet, the person is born, the person then travels back, stops the parents meeting, and then in that parallel universe, which is my own version of a parallel universe, they never meet. She's never born.
I don't think you're allowed to do that, really, because essentially, at the macroscopic level, you have identity, which you don't have at the quantum mechanical level. You don't have any things at all. You have various states and so on and so forth, and they can be parallel. But she could not exist, and it couldn't be the case that she exists and she doesn't exist simultaneously. In other words, she couldn't have, when you're talking about macroscopic entities that have identity, it's not possible to have those two states simultaneously in a way that it would be at the quantum level.
Okay.
Why not?
It just basically, because if something has a certain identity, it cannot exist and not exist. It's a logical impossibility.
Okay. Well, look, we'll move on. I think looking at the chat room, I think Peter has got a has got a solution to the issue of the materializing in the past time traveler. And so, Peter, do you want to sort of give us your solution, and then Raymond possibly can comment?
It's not very complicated. I mean, just as a general intro, I'd say that it's very hard for us today to imagine what is possible in the future. In the same way that if you went back a few hundred years, I'm quite sure that it would be quite inconceivable that people would imagine that we're able to send objects into space and view the galaxies in the way that we do. So it's hard to predict what could possibly happen. But the answer to materializing inside a structure is very simple. You simply have a time machine that is above the Earth in space that could not be inhabited in the past by any known structures, and thereby you could time travel back quite happily, knowing that if you re-emerged at 2,000 feet, you'd have a high probability of being perfectly okay.
Right. So
weather permitting, perhaps.
Okay, I want to pick up on your general point first, and then, of course, you're absolutely right. It's always dangerous. The future is unpredictable, just like in Soviet Russia is the past as well. So basically, it is very tricky. I can imagine if in 1880 I was told in 100 years' time that we'd be able to talk to people in Australia by bouncing a message off a satellite without even raising our voice, I would be among those who was falling about laughing and so on and so forth. But here, what I'm not predicting the future. All I'm saying is the reasons for people arguing that time travel is possible on the basis of basically relativity don't actually deliver time travel. But your second point, I'm not very clear. When you say outer space, I don't quite understand how that would solve the problem of the time traveler. So you'll have to bear with me.
One of the time traveler is that you depart from your current time in 2020, and you emerge in 1066. You emerge in the middle of a building, some sort of structural object, which obviously is going to be somewhat detrimental to your future existence. And one way to avoid that would be to simply emerge in space above the Earth.
Oh, that's not a problem. I mean, basically, it doesn't matter whether it's inhabited or uninhabited. It will have had a certain state in 1066 and a different state in 2020, irrespective whether it's buildings or battlefields or just lumps of rock. So the fact that it's not developed by humans doesn't in any way alter the physical barrier
But
to, as it were, arriving at a place that would be required to have two states.
But there were no satellites in 1066. So if you emerged above the Earth in 1066, you could be reasonably confident that you weren't going to suddenly emerge into a satellite or something. So you just do it in space.
But space still has features, and features that change over time. I mean, if we're talking about yes, if we're talking about emerging into a vacuum, that's not terribly hospitable. But clearly, you're thinking about uninhabited space, but it still changes and evolves over time.
Yes, meteorites is a good point. But you'd have to be a bit unlucky. I'm no expert. It was just a thought that occurred to me, probably quite foolishly.
No, I think it's a point well made. I think the idea is clearly that uninhabited space, according to Raymond, is not really the fundamental point, I suppose, is what
That's
Raymond,
right, yeah. It's a question of a world that changes, a universe that changes, and it doesn't matter whether it's replacing battlefields with housing estates or whether it's replacing one rock with another rock.
Yeah. Good. Who else wants to go next? Mike, why don't you go next?
And thank you very much, first of all, for your stimulating talk. And
thank you.
I'd like to pick up a few points in it. I think that our perception of time doesn't necessarily find itself at odds with physical time, by which I mean sort of scientific time, the time of velocity, the space-time continuum. We perceive a lot of physical phenomena in a different way personally. Even distance is relative to us. Heat is relative. So it doesn't seem to me to pose too much of a problem to say that there is this physical entity which we to some extent experience, but we don't experience exactly, because that is common to a lot of physical senses. And I'd go on from that to look at this whole business of time travel. There is an innate paradox in time travel, but it depends what you mean by time travel. If you mean by time travel actually going back into the past and being an active agent in that past, there is an insurmountable paradox. Because if that sort of time travel exists in the future, then it would always have existed. Because that time traveler would have been there with their time traveling machine from the beginning. If time travel means that in some way you can travel back as an observer who is not able to interact with the past, then I suppose that might be a possibility. But certainly the other one seems to be completely ruled out by that paradox that if there's going to be time travel, there would have been time travel. I don't see there's a way round that. There's one other a little point, which is always a niggle, when people talk about the third law of thermodynamics. They always forget the second law. Well, the second law and the third law, yeah. There's an important thing they always forget, which is that it was in a closed system, which is always a problem because you're not sure what the closed system is in sort of more broad context. So it isn't quite as inevitable as it seems, but that's only a passing thought about it. But you have to remember that it's a closed system, and you don't know what's outside that closed system feeding into that system. It may make it not a closed system. But anyway, I leave you with those sort of random thoughts.
Well, just to go back in reverse order, I mean, basically, I don't think the second law of thermodynamics is confined to a closed system, because it's one of the understanding is the universe as a whole is becoming has increasing entropy.
Yep.
And that's one of the big puzzles is how it began in a low entropy state. It's only a closed system when we're thinking of basically about usable energy. And so
I think
when we're translating into available work, I should say, yeah. But
if you look at the universe in that way, it is a closed system. The whole universe is a closed system.
Okay, that's fine. In that case, that's fine. I mean,
it depends what you mean by the word universe, of course.
Well, I'm happy. The sum total of absolutely everything. So, I mean, I thought when you meant, I mean, there's two ways of looking at the second law of thermodynamics. One is to basically see it in relation to available energy that can be usefully used and not squandered, and the other is to see it in terms of basically gradual de-differentiation towards equilibrium, when everything is basically dissipated towards equilibrium, and that is something that basically can be extrapolated universe-wide. So I'm happy to have that, and so. But you made a very good point, and I'm annoyed with myself because I've just forgotten it. But oh yes, you were talking about it to be okay just to observe, you know, as long as you didn't interfere with everything. But actually, in order to be there, you'd have to be alive. So you've got to breathe. And the butterfly principle, one exhale breath, and you could
yeah,
and even one can only assume being aware of what is out there must involve some kind of interaction with it. Just as my awareness of you, just looking at you, I'm having some kind of immediate interaction. So my argument is that the poor time traveler cannot even be aware of the place she has landed at without potentially causing a disturbance that ripples out, that leads to a future in which she doesn't exist. Does that make sense?
I tend to agree with you. I was just offering it as a sort of hypothesis. I tend to think that the problems you find with it are probably correct. However, I just come back on the universe thing. The problem of universe is used in the word is used in two different ways. It is used to mean this universe, and it is used to mean everything that possibly does or could exist. Yeah. And I think that's where confusion lies, in that specific use of the word and in the general use of the word.
Yeah, I think of the universe as the sum total of absolutely everything from the beginning to the end.
Okay,
but then there could be something outside of that universe.
Yeah.
Almost by definition there couldn't, because that would be part of the universe.
In that case, that's not the same as this universe, which started with the Big Bang.
Well, I suppose that's true. That's interesting, isn't it? Yes, because, I mean, if you take Lee Smolin, he thinks of a series of universes.
Yeah, sure.
Yeah.
You see, if the producers of the film series of Back to the Future had travelled forward to this day and taken stock of all the Q&As and all the presentation today, it would have been a much more interesting film series. Very good. Don, you want to go next?
Yes, I was just going to talk about time. We've been talking about time travel to the past, but time travel to the future is obviously perfectly feasible by some form of suspended animation, although there'll be no return ticket. But the other thought is that if the world is in fact completely deterministic, then it should be possible in principle, although almost certainly quite impossible in practice, to reconstruct the past times or the events of past times, and hence to effectively go to past times as an observer, but without, of course, the ability to interfere.
Taking that last point, we covered that just now, that any observation or being an observer would interact with the world and therefore could set off a ripple of events. But talking about travel to the future, suspended animation wouldn't be time travel. Supposing you put me in a state of suspended animation now, and I was put in suspended animation for 10 years, it would take 10 years. I wouldn't, as it were, be getting ahead of time by being in a state of suspended animation for 20 years in 10 years.
Subjectively to you, it wouldn't. It'd be like waking up after a medical anesthetic.
Well, that's not time travel. You know, if I'm put to sleep now, and I'm asleep for 12 hours, and wake up in 12 hours' time, I can't account for those 12 hours, but I haven't got ahead of time. I haven't, as it were, been propelled into a future ahead of the universe.
But the thing about going into the past by reconstructing a deterministic series of causes, in principle possible, but of course completely impractical.
I'm not even sure it's in principle possible. That's the whole burden of my talk, was it was in principle impossible. Never mind whether it's practical or not. Yeah.
Well, it depends if the universe is deterministic or not, which we can never be quite sure.
I don't think it even depends on whether or not the universe is deterministic. It's a question of whether or not you can go backwards. Well, I suppose causation is a kind of expression of determinism. But it's just the general principle that if you're going to do anything like traveling, you're going to have to rely on a universe that has laws and principles which you can exploit in order to have your journey backwards. But of course you can't, as it were, go back from effect to causes and still, as it were, exploit the laws of nature. You're going against them.
Of course, from present observations, you can deduce what things were like in the past to some extent. Any detective trying to find out about a crime is doing just that. But of course, it's not complete, and we couldn't go back hundreds of years to find detailed events.
I mean, if you gave me a bone from the Battle of Hastings site, and I was able to date it and say this is, you know, this must have been a warrior who was killed on the battle, I wouldn't be traveling in time. I'd just be dating something that happened in the past.
We'd just be finding out as an observer. You wouldn't be there.
That's a different kind of observer. I'm not even an observer in that sense. I'm making some inferences. I'm not looking at what happened at the time. I'm not present, as it were, in that past, if you see what I mean.
Okay.
Okay. Okay. There must be more takers to take you on, Raymond, for the notion of time travel. I think Victoria would like to ask a question.
Raymond, thank you so much for a fascinating talk.
Oh, thank you. Yeah.
Thank you. I'm not a philosopher, so I must state that at the outset. And I don't want to pour sort of cold water, so be a Puritan and throw cold water on a philosophical premise. But because what I'm interested in is the ethics of how we frame time, and that does, you know, that then again that brings in a kind of normative, or you know, a dubious sort of Puritanism, it feels like. But actually what it feels like listening to you talk and discuss the issue is how important these questions are in terms of almost kind of flipping it back. Some of the questions you asked about, or the statements you made about what the time traveller is not able to do, I think as important flipped in terms of what we are able to do. And I suppose I'm interested in an artist called Joseph Beuys, who's interested in adding warmth to time. He kept talking about that the Earth is a warmth time machine, and I'm just putting, and I've always didn't really understand what he meant by that. But when you were talking about living alongside Earth time, or I wrote down we live alongside Earth time. But I suppose, sorry, I'm slightly gushing, but I think what I'm trying to grasp at is what our questions offer us in terms of contemporary work with time as we are able to shape it. So horrifically, that point of, you know, you couldn't murder, they could go, the time traveller could go back, and the one thing that they couldn't, they would affect everything in the field, you know, and they couldn't, if they murdered their parents, obviously it meant they'd never through time do terrible things that I want to intervene in and use materials to change people's behaviour. This is very left field, I'm sorry, but I first found it so fascinating to listen to, you know, what philosophers talking about time can offer in terms of ethical action.
I think that's a really interesting question. I mean, I have a soft spot for Beuys. My son used to have the famous sledge, you know, as a poster on his wall, and he's a great fan of Beuys. So we've had lots of Joseph Beuys discussions. I beg your pardon?
Conversations about his work and so
absolutely on. Absolutely. It seems to me that one of the questions about not being able to travel in the past, and really touches on what you said, is how one can redeem what has happened. How can we reverse what has happened? How can we, as it were, take back what has happened? And I think people often say, if only I could go back to last Tuesday, I would have behaved differently. That anguish of not being able to time travel and readjust things, and it, you know, that's totally what you've hit the spot on the ethical dimension. Yeah.
And also potentially a political dimension in terms of, gosh, flipping back, we can affect things, we can act, we can, you know, all the things the time traveler would not be able to do, we can do. Yeah. As it's where the future lies, something that we can shape to some extent. The past, as I say, they always said, you know, the future is unpredictable, and in the Soviet Union, so is the past. But it just seems to be one of those things that perhaps it emphasizes our utterly privileged condition in the now, that we can change what is not yet happened, because there's no way we can reverse the past in any way. Oh, well, thank you for raising that dimension, because it is, But so important to have those discussions and think about time in all sorts of ways because of what it can afford.
Yeah, absolutely. Yeah.
Thank you. I'm gonna hide away now again. Sorry, I'm not very good on it.
No need.
Okay, excellent. Now it's coming up to 9 o'clock. Maybe we've got time for another couple of questions before we close at 9 o'clock. Is there anybody else? I see that Baz has got another question he might want to ask in person, or do you want me to read it out for you, Baz?
No, I was intrigued by the thought that time travelers, if it would be possible, they would have been all around and for a long time. So we would be in some way, hopefully, be able to detect them. Now, if they can only observe, we may not. But my question is, could we or how could we infer whether there are actually time travelers walking around? Or have been in history?
What an interesting question, blimey, yes. I mean, I think I feel reassured that the very physics that seems to indicate that time travel is possible actually makes time travel impossible. So I'm not aware of any physics that would make it seem that time travel is possible. But you may say you're looking in the wrong place when you're looking at physics. But it would be interesting, wouldn't it? We're surrounded by people who've arrived in, Tuesday from other places. Difficult to know how, as it were, they would have arrived, by what means.
Yes. Well, I suppose we would have known whether Adam and Eve have arrived because of the way they dress.
Absolutely. It's sort of, and they come armed with apples and things, I suppose, so it would betray.
We would be able to differentiate unless the clothing changes as they travel as well. So
that's a possibility. Absolutely, yes.
So watch out for different dress senses from different epochs.
Yes, yeah.
Great. Anybody else before we close proceedings for tonight?
Oh, can you hear me,
Yes, Robert, I can hear you. Excellent. Do you want to ask a question?
It's just to say, unfortunately, my computer won't travel back forward in time in order to give a picture of me. But it's an old friend of yours, Raymond, Robin Philpott, who now lives in Bath.
Wow, hello there.
So we have actually managed to travel back 30 years tonight.
Absolutely.
People might not know, but your day job was as a geriatrician and mine was as an old age psychiatrist. And we had lots of patients who would actually live their lives in reverse as their dementia got worse.
Absolutely. God, yes, that was right. Yeah.
It was a fascinating experience as a clinician. But I have got one serious, semi-serious question, and that is, what happens to time if you disappear into a black hole?
The answer is I don't really know, because, I mean, if we're talking about perception, I mean, if we're talking about objective time, I think it freezes. But if we're talking about the perception of time, given that it's not associated with any conditions you can survive, I'm not too sure. I've always had trouble with black holes. They sort of seem to promise metaphysical revelation, but nothing comes out of them, although I know Hawking radiation does. But nothing metaphysical comes out of them. So, Robin, I have to apologise, but fantastic, Mossley Hill Hospital, etc.
Absolutely. Well, I was all about 10 about 5 years ago to move down to Bath, and I'm a very happy member of what we know down here as Brisley.
Yes. Oh, excellent.
The Bath Society.
Yes, well, thank you very much for that. It was great to have someone to actually prove that we have travelled back 30 years in time after all today. So,
Robin was fantastic. Yeah.
And I'm sure the two of you will sort of catch up after this.
Great working relationship we had.
That's brilliant. Okay, one more question from someone, if they want to raise a question, and then we'll draw to a close. Does anybody want to ask a final question? Phil, please ask your question.
I think it's on.
Oh, Phil, we can't hear you, unfortunately. You're not on mute, but maybe your speakers on your computers aren't activated. No, sorry, we can't hear you. It's a shame, but I mean,
sorry about that.
Yes.
Could you do it by chat?
Well, yes, I was going to suggest maybe, Phil, you can write it down in the chat facility and I can read it out before we sort of close. But whilst we're waiting for Phil to put it into the chat room, could we all unmute ourselves and give Raymond a big applause for tonight's excellent presentation?
Thank you for having me.
Very much.
Thank you. And by the way, I'm always up for any excuse to go down to Bath, so I shall be shameless in pursuit of coming down to Bath. But I absolutely love that town. My wife and I dreamt of basically moving to live there, but we found every house we fancied we couldn't afford, and what we could afford wasn't quite what we wanted. So we left with our tail between our legs, but we love Bath. Yeah.
Well, I'm sure Raymond will be delighted to welcome you back again, and hopefully this dreadful virus will be gone by that time.
Oh, well, thank you, Don. Yes, absolutely. And back to martinis, perhaps. Yeah.
Yes, indeed.
Absolutely. Why not?
No, we would love to have you back in 2021, Raymond. That'd be great. Just to sort of let everybody know, I'm looking at Phil. Unfortunately, hasn't used the facility, so we'll draw it to a close. But I just want to mention a couple of things. Dom and I are still pursuing Simon Blackburn to give a lecture in October. But we have been unable to connect with him recently. He's got it in his diary. We just need to make sure the 6th of October is something that will come to fruition. I'm going to chase Simon Blackburn up on his talk in October. In November, we have a talk by Jeremy Comerford, a BLSI member, on the philosophy of John Locke. That should be quite interesting. He was born not far from Bath, in a village called Rington, which I used to live in some time ago. So again, a local lad, so to speak. So the philosophy of John Locke and his materialist views would be really interesting to everybody. And then in December, we have Professor A.C. Grayling coming to give us a talk on the history of philosophy.
Wow.
So that should be quite interesting, and that's in December. So something to put in the diary. I'm sure Don and I will write to you regarding next month in October. If we can't get hold of Simon, we'll come up with something else and potentially do a salon, a cafe philo or something like that, where we discuss a topic in an interactive way with everybody. I think it could be one alternative. But we'll keep you posted. So hopefully we'll see each other in October. You know, as they say in these pandemic times, stay safe, stay healthy, and increasingly stay sane. I wish you a very good evening, and I shall see you in October. All the very best.
Thank you all for listening. I've enjoyed the questions very much. Thank you.
Bye-bye, everybody. Thank you, Raymond.
Bye.
Bye, Sally, as well. Bye, Chrissy.